this one says return to 729 and find the approximate probability that the random sample of 100 will contain 24% or more orange candies. Okay, so what is the probability that the sample of 100 candies will have 24% or more orange? Okay, so 729 said that P, the proportion that's orange, is 0.20, and we are taking samples of size 100. Alright, so based on this, okay, we can check our conditions. The first condition is that it's independent and random. And that checks out because it says the candies, we're examining 100 random candies. Okay, so that checks out. And then we want to make sure our sample is large enough, so we have a large sample. So to check that, we have to do n times p and make sure that's bigger than 10, and we also do n times 1 minus p and check if that's going to be bigger than 10. So here I've got n is 100 and p is 0.2. That gives me 20. That's bigger than 10, so we're good. N is 100. 1 minus p is going to be 0.8. That gives me 80. So we're good. And finally, I want to make sure I have a large population or big population. And so is 100 candies more than 10% of all M&Ms ever? No. It's not, so we're good. Alright, so when all of these things check out, we can use the normal model. So we know that p hat, every time we take samples, p hats will follow a normal model. And the mean of this normal model is p, and the standard deviation of this normal model is the standard error, which is the square root of p times 1 minus p over n. Alright, so the mean is going to be 0.20. Standard error, which we found back in 729, I'll do it very quickly again, is 0.2 times 1 minus 0.2, which is 0.8, divided by n, which is 100, and this gives me 0.04. So now I've got a normal model with mean 0.20 and standard deviation 0.04, and it's asking find the probability that the random sample of 100 will contain 24% or more orange candies. At this point, this is a normal model problem. In the center, I've got 0.20, and I'm drawing a cutoff line at 0.24, and I'm looking at 0.24 or more. My z-score is going to be the cutoff, 0.24, minus the mean, which is 0.20, divided by the standard deviation, 0.04. This gives me a z-score, when you punch that in, of 1.00. I go to the back of the book, and I look up the area to the left of 1.00. So from the z table in the back, the area to the left of 1.00, or probability that z is less than 1.00, this is 0.8413. This is the number that you get from the z table, which means the area over here is going to be 1 minus 0.8413. This gives me 0.1587. This is my answer. Alright, so again, this is not any more complicated than a normal model problem, but you just have to figure out the mean and standard deviation first. So what is the probability that a sample of 100 candies will have 24% or more orange? The answer to that, 15.87%. That's the probability there.